Hello students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttankarai. In last session, we discussed about hybridization and the shapes of reactive intermediate and the nucleophile and electrophile. Now, in this class, we may discuss about electron displacement effect on covalent bond and inductive effect. So first we move on electron displacement effect in covalent bond. And in organic chemistry, some properties, some properties like stability and reactivity and basicity and acidity, these are depends on the electron displacement effect on a covalent bond. And this electron displacement effect depends on, so this electron displacement effect depends one atom or group attached with the covalent bond. So the atom or group attached to the covalent bond. Attached to covalent bond. Covalent bond. And the second one, the reagent like electrophile or nucleophile approaching the covalent bond. So the reagent approach the covalent bond. Covalent bond. So this atom or group attached to a covalent bond or the reagent approach to the covalent bond is dependent the electron displacement effect. And this effect may be permanent. This effect may be permanent or temporary. This effect may be permanent or temporary. In some cases, what will happen? The permanent polarization occurs. So, in some cases, permanent polarization occurs. Permanent polarization occurs and which leads to fission of bonds. So the bond may be break. So it will be leads to fission of covalent bond. Fission of covalent bond under certain reaction condition. Now this electron displacement effect is classified into 4 types. One is inductive effect. What is that? Inductive effect. And second one, electromeric effect. And the third one, resonance effect. Resonance effect. And the fourth one, hyperconjugation. So it is hyperconjugation. So the electron displacement effect are called as electronic effect. They are classified into 4 types. One is inductive effect, electronic effect, resonance effect and hyperconjugation. Now we may see one by one. The first one, it is inductive effect. What is that inductive effect? Listen, in a covalent bond, The permanent polarization of covalent bond. Permanent polarization of covalent bond is due to presence of highest electronegative atom is nothing but inductive effect. So it is defined as the permanent polarization of covalent bond due to presence of highest electronegative atom. Due to presence of highest electronegative atom or group, then it is known as inductive effect, and this effect is permanent effect. So what is inductive effect? It is due to permanent polarization of a covalent bond in presence of highest electronegative atom. And first we may take that electronegativity. What is an electronegativity? It is a periodic property. Then the shared pair of electron will move towards on highest electronegative atom. Then it is known as electronegativity. And in electronegativity, in the period it is increases. So if you are taken, that is boron, carbon, nitrogen, oxygen, fluorine, and these are the highest electronegative atom. So fluorine has highest electronegative atom in the periodic table. After that, oxygen and nitrogen. Now we may consider a non-polar bond. How will you get a non-polar bond? Listen. Equal electronegative atoms are bonded. Suppose carbon is bonded with the carbon. Now these two are equal electronegativity. Now we may say that the ethane molecule and here hydrogen, and same as hydrogen and hydrogen. Now this CH3 and CH3 is bonded with that by a covalent bond, and a bond is made up of 2 electrons, and the 2 electron is present at the center of 2 atoms. It cannot move any one of the atom. Now it is considered as a non-polar covalent bond. Non-polar covalent bond. So a non-polar covalent bond is formed by equal electronegative atoms are bonded together. Now consider when different electronegative atoms are bonded. Listen, now we may take that here CH3, that is CH3 and CH2 and CH2 and Cl. Now compare that, all are carbon, and here carbon is bonded with that chlorine. Now which one has highest electronegative atom? Comparing carbon and chlorine, we may compare that the electronegativity of an atom. Here carbon has less electronegativity than that of chlorine. So chlorine has highest electronegative because it is present in that end of the periodic table. Electronegativity increases in the period. Now what happened here? The bond pair of electron between carbon and chlorine is moved towards that chlorine because chlorine has highest electronegative. Remember, what is that electronegativity? the bond pair of electron is attracted towards the highest electronegative atom. Which one is highest electronegative? Chlorine is highest electronegative. So, the bond pair of electron is made up of 2 electrons. These 2 electrons is not present at the center of this carbon and chlorine. It will move towards that chlorine because of highest electronegative. So, what happened in the case of chlorine? There is a partial charges, that is negative charges created at chlorine because it has highest electronegative. The electron density around chlorine is increases. Electron density around chlorine is increases. So, it will get partial negative charge. Now, which one is a loser? Carbon is a loser because of lowest electronegative. So, here there is a creation of partial positive charge. There is a creation of partial positive charge. Listen, in inductive effect, we cannot transfer the bond pair of electron from one atom to another atom. It is not possible in inductive effect. Only the charge density around that highest electronegative atom is increases, so that there is a creation of partial negative charges on highest electronegative atom. Now, what will happen the further move? We are taken here, that is CH3, that is hydrogen and hydrogen and hydrogen, and here hydrogen and here hydrogen, and we are taking propyl chloride, and here it is Cl. Now the bond pair of electron will move towards that highest electronegative atom, that will be represented by an arrow mark, so that electron density around the chlorine increases and it is getting that del negative charge. Now it is C1 carbon, and it is C2 carbon, and it is C3. Now on the first carbon it is getting del positive charge because of lowest electronegative. Now what will happen further? Listen, now this bond is polar, so it will be moved towards the chlorine, and now this bond is also polar. It is not a non-polar like a ethane. Why? Because in ethane it is all are equal electronegative atom, so that in ethane it is a non-polar, but it is not equal, so that the magnitude of charge will be created on C1. So on C2, to compensate this positive charge, to neutralize this positive charge, what happened? The bond pair of electron will move towards that C1 from C2. So the positive charge will be created, but it will become very weak. It is already on C1, partial charges will be created. And to neutralize this positive partial charge, the bond pair of electron in a covalent bond will move towards C1. So, somewhat weak partial charges will be created on C2 carbon. Now, it will be extended only up to third carbon. So, now it is also a polar bond. Now, the bond pair of electron will move towards from C3 to C2, so that there is a del and del and del charges will be created, that is positive partial charges will be created. Now this magnitude of partial positive charge decreases from the active group. It is an active group because it is highest electronegativity group. Now the charges created at C1 is somewhat high, then C2 somewhat low, and in the case of C3 then it will be decreases. Now we may conduct we may take in a bond. It is first bond, second and third and fourth bond after 4 bonds or after 3 carbon. The inductive effect is vanishes. Inductive effect is vanishes, and it is a permanent effect. It is a permanent effect. So it is a permanent effect, so that it will be produces the permanent polarization. Now we may take that here it is electron withdrawing group. Depending upon the ability of atom or group which donate or withdraw the electron density attached to the carbon, we may classify 2 types. So depending upon that ability, we may take that here inductive effect is classified into 2 types. Why? It is depending upon the ability of electronegative atom which can donate or withdraw. And here we are classified into 2 types. One is electron withdrawing group. That is called as minus I group. Minus or negative inductive effect group. These are all electron withdrawing group. Now, electron donating group, they are called as plus I group. So, depending upon the ability of atom or group attached to the carbon, inductive effect may be classified into 2 types: electron withdrawing group and electron donating group. Now, we want to see the order of electron withdrawing group and electron donating group. Now, we may take the order of electron withdrawing group, that is minus I group. And the order is the NH3 plus. It has highest electron withdrawing group. And after that NO2 and Cn and SO3H. So ammonia positive, so that it is ammonium, and nitro group, cyano group and sulfonic acid. And after that here it is aldehyde and ketone and acid chloride. Aldehyde, ketone, acid and acid chloride. And after that amine and fluorine, chlorine, bromine and iodine. Then after that here OH group and RO group, alkoxide group, and NH2 amine group, and C6H5 phenyl group and hydrogen. So these are the order. We want to memorize it. So it is electron withdrawing group effect. So here NH3, NO2, Cn, SO3H, aldehyde, ketone, acid and acid chloride, amine, fluorine, chlorine, bromine, iodine, OH and alkoxide, amine and phenyl and hydrogen. These are order of electron withdrawing group. Now it is electron donating group, that is positive inductive group. Then the order of positive inductive group is tertiary, CH3 thrice C. Then tertiary alkyl group has maximum positive inductive group. Then after that it is secondary, CH3 twice CH, and it is secondary alkyl group. And after that it is primary, CH3 and CH2 group. So primary, and after that it is methyl group. So we are taking two types of inductive group. One is positive inductive group and negative inductive group. What is the effect in organic compound? We may see in examples. Now we are taking the application of inductive effect. The first application, it will be explain the stability of carbocation and carbanion and carbon free radical. We are already saying it is a reactive intermediates. So it will be explained the stability of carbocation, carbanion and free radical. And it is also explain the reactivity of alkyl halide, and aldehyde and ketone towards nucleophilic addition. Nucleophilic addition reaction. So we may explain by inductive effect the reactivity of aldehyde, ketone and alkyl halide. And the third application, it will explain the acidic strength of carboxylic acid. Acidic strength of carboxylic acid. RCOOH is carboxylic acid. Then it is also explained the basic strength of amines. Now we may see these two, that is reactivity and that acidic strength of carboxylic acids. Now the first one we are take, that is reactivity. Now we may take an example, that is tertiary butyl bromide, that is CH3 and here CH3 and here CH3 and bromide, tertiary butyl bromide. Now on nucleophilic attack, now it is nucleophile. And what is the charge of nucleophile? Nucleophiles are negative charge. So negatively charged nucleophile is going to attack a carbon. Now what will happen here? We may take that this carbon Br bond become polar. If it is a polar, there is a possibility of inductive effect. If it is non-polar, there is no possibility of inductive effect. Now this bond is polar. So what will happen? The bond pair of electron will move towards bromine. So that bromine has partial negative charge and here partial positive charge. So the electron density around that carbon will decreases, so positive charge will be created. Then what will happen? Here the nucleophiles are negative charge. So the nucleophile is easy attack on that carbon. So the reactivity of carbon will increases. That will be explained by, that is minus I effect. Correct? Here Br is a minus I group. It is electron withdrawing group. Due to minus I effect, the reactivity of tertiary butyl bromide increases on nucleophilic addition. Now we may take the second one, aldehyde and ketone. Suppose we are taken the aldehyde and ketone, that is Cl and CH2, C double bond O and that H. Now it is aldehyde. In the case of aldehyde, what will happen? Here it is the minus I group. Which one? Minus I group. Chlorine is a minus I group. So what will happen here? The bond pair of electron will move towards that chlorine. So it is getting del negative and getting del positive charge. Now, already what will happen? The oxygen is highest electronegative, so that the bond pair will move towards that oxygen, so that the carbon has the net positive charge due to pi bond movement. Pi bond is converted into, that is a lone pair here. Now, here the positive charge will be created, and here this bond is also polar, so the movement of a bond pair towards that CH2. So furthermore, the electron density on that carbonyl carbon decreases, so that the nucleophile, the negative nucleophile, which can easily attack on a carbonyl carbon, it is due to minus I effect. So this minus I effect or inductive effect explains the reactivity of aldehyde and ketone and alkyl halide. Now, strength of carboxylic acid. Now, first one, minus I effect. Minus I effect on carboxylic acid. Now, compare acetic acid, that is CH3, C double bond O, OH. It is a carboxylic acid. What do you mean by acid? Acids are the substances which produces H plus ion. They are called as acid. So, we may take, these are the substances which produces H plus ion. So, it will produces H plus ion and remaining CH3, C double bond O and O minus. This is acetate anion. Acetate anion. Now, this acetate anion is resonance stabilized. How it is resonance stabilized? Listen, it is resonance with, here the lone pair will converted into bond pair, and now the bond pair is converted into lone pair. So that here it is CH3 and C and O minus and double bond O. So it has two resonance structure. It is first resonance structure and this is second resonance structure. So a acid is present at its conjugate base and proton. These are nothing but conjugate base. Conjugate base. So removal of proton from an acid is nothing but conjugate base. Suppose if you are taken HCl, then it is an acid. What is its conjugate base? Cl minus is a conjugate base by removing of H plus. The same way here acetic acid, its conjugate base is acetate anion, and this acetate anion is more stable than that of acetic acid, so it will be produces H plus ion. It will be produces H plus ion. Now, we may take that acetic acid is compared with chloroacetic acid. We may introduce a minus I group into acetic acid. Now compare acetic acid, that is CH3, C double bond O and the OH. And chloroacetic acid, here we are introducing a minus I group, that is Cl and CH2, C double bond O, O and H. Now it has a minus I group, chloroacetic acid. Now what will happen? It has a minus I group. What do you mean by minus I group? These are electron withdrawing group. So what will happen here? The bond pair of electron will move towards that chlorine, so that it will get partial negative charge, and here it is partial positive charge, and here the positive charge will be created here. Now here what will happen? The OH bond is easily cleaved because of minus I effect, so that it will be easily produces its conjugate base, which is most stable. So comparing acetic acid and chloroacetic acid, H plus is easily produces from chloroacetic acid, so that it is the strongest acid than that of acetic acid because of minus I group. Then if we introduces more minus I group, then acidic strength is also increases. So minus I group increases acidic strength of carboxylic acid. Acidic strength of carboxylic acid is also increases. So number of minus I group, suppose we are taking chloroacetic acid and dichloroacetic acid. So here it is chloroacetic acid, CH3, CH2, C double bond O, OH, and dichloroacetic acid. Dichloroacetic acid, that is COOH. Comparing these two, which one has more acidic strength? That is dichloroacetic acid, because it has 1 plus minus I group, and here it has 2 minus I group. So that the effect is more. Here it is move towards the chlorine and chlorine, and here the movement is high. Here the movement is, it will be moved towards the chlorine, and here it will be moved 1 times, but it will be double the time. So the OH bond become weaker and weaker, so that it will be produces the stable conjugate base. So chloroacetic acid and dichloroacetic acid. Dichloroacetic acid has highest or strongest acid. The same way trichloroacetic acid has very strong acid. Now we may take that plus I effect on carboxylic acid. So plus I effect on carboxylic acid or COOH. Now compare that HC double bond O, OH. Formic acid and acetic acid, CH3C double bond O and that OH. If the OH bond is stronger, it cannot produces H plus ion, then it will become weakest. Now we may take that formic acid. In the case of formic acid, there is no plus I group, and hydrogen has very least plus I group. So that here what will happen in acetic acid, then CH3 methyl group. Plus I effect is in the order tertiary, secondary, primary and methyl group. So that it may act as a plus I group. So what will happen here? And it will be donate the electron pair through the covalent bond. Then it will repel, so that here it is getting del negative and here it is a del positive. It is del positive. So here it is also donated, so the OH bond becomes stronger. The OH bond becomes stronger. So comparing formic acid and acetic acid, and here there is no plus I effect, but here it is a plus I effect. So compare these two. Formic acid is the strongest acid than that of acetic acid. Now acetic acid, we have compared CH3, C double bond O and OH, and here CH3, CH and C double bond O and that OH, and here CH2. Now acetic acid and that propanoic acid. Acetic acid and propanoic acid. Now comparing methyl and that ethyl. Methyl group, and it is a primary group. So the order tertiary, secondary, primary and that methyl group. So it is a primary. So compare these two effects. Which one has highest plus I group? It has highest plus I group. So it has highest plus I group than that of this methyl group. So when plus I group increases, the OH bond becomes stronger and stronger. If the OH bond is stronger, then H plus cannot be removed from that acid. Then it cannot produces a conjugate base, so that it will become a weaker acid. So we may compare acetic acid and propanonic acid. Acetic acid is the strongest acid. The same way, the number of plus I group increases. Number of plus I group increases. Then the acidic strength of carboxylic acid decreases. Acidic strength of carboxylic acid is decreases. So these are the effect of acidic strength on plus I and minus I group. Dear students, in this session we may take the inductive effect, the most important effect, inductive effect, and it is classified into plus I and minus I and its application, and also electronic effect and electronic movement on that covalent bond. So go through your state board book and NCERT book. Thank you.